Hi, 11th graders. We are starting our last unit or our last lesson for this unit. So at the end of this lesson, this will be all of the things that will be coming up on your upcoming test. Your test is going to be next week on October 5th or 6th, depending on which section you are in. So you are about a week out from your test, which we talked about in class. So just letting you know that that is on the horizon, that is coming up. It covers rounding and scientific notation. It covers bounds. It covers scientific notation. Significant figures and scientific notation and bounds. And then it covers triangle trigonometry, so Pythagorean theorem, SOHCAHTOA trigonometry, law of sines, law of cosines. It covers finding the area of regular polygons by splitting it up into equal triangles, and it covers arc length and sector area, and it covers 3D geometry. So there's a lot that's being covered in this unit. So just be aware that there's a lot going on and a lot to study. You will have a review packet. It will be available to you soon with an answer key and all of that. And we'll have a full day designated in class for review. I highly recommend getting started early and practicing. And if you are unsure what to study, my first recommendation would be to go back through and find all of your checks for understanding and open those guys back up, and they should be ready to go and available for you for additional practice on all these materials. So you've got a lot out there to help you prepare for this test. All right, 3D geometry. There's a lot that goes on with 3D geometry in terms of finding missing pieces. It's a very common IB question, especially with geometry in general, because being able to puzzle together a three-dimensional figure is something that's important if you're talking about applications of real world. A lot of these formulas are in your formula packet. The main thing though is that they're not in your formula packet as just one formula. They want to see whether you can piece together what the side lengths are and what the surfaces are without giving you just a formula to use. And so, for instance, okay, so the volume of a pyramid is in your formula book. It's on page 6 of your formula book. I would recommend having that out and available, or like split screen or something like that, so you can see your formula book as we're going through this. The volume of a pyramid is 1/3 times the area of the base times the height. Notice the height is from this vertex down to the base. AB is area of base, H is height. So this is in your formula book and it's on page 6. Now the surface area is not in your formula book. So the IB needs you to be able to understand how to break this guy into all of their different surfaces. So there's that base there. So your surface area is going to be that base, which here it looks like a square, but doesn't have to be a square. So area of the base plus, we're going to always assume that it's, this formula is assuming that the base is a square, because all 4 of those triangles would not be an equal size if all of these side lengths are not the same, right? So then some of them might be skinnier or some of them might be fatter if it was a rectangle on the bottom. So just realize that you have 4 triangles that you then need to add up in terms of the surface. And if it's a square, then all 4 of those triangles will be equal in size. But if it's a rectangle, then you have 2 triangles on one side that are equal and 2 triangles on the other side that are equal. So like 2 triangles, like the back guy as well as this front guy, and then the 2 side lengths would be different if it was a rectangle. So this is me talking really fast, trying to explain to you about how to break down the side lengths here and the side faces here. And it's just something you have to practice being able to see and practice knowing. And so that's what we're going to spend today doing, as well as in class. Okay, cone. A volume of a cone is also in your formula book. It's also on page 6. It's also 1/3 times the area of the base times the height. Just in this case, the area of the base is a circle, so the area of the base is pi r squared. Again, this is in your formula book. I think they even put pi r squared into AB. So it's, I think, 1/3 pi r squared h. So yeah. The surface area, again, is that base, so area of the base, plus, and then pi r s represents they call it a lateral surface area, and a lateral surface area is what wraps around the side of this three-dimensional shape. S, as you can notice, is here, this length that is the diagonal length, the lateral length, as opposed to the height, which is the straight up and down. Please realize that they make a right triangle. That's a very common IB question for you to be able to realize that there's right triangle trigonometry in here that you can figure out. And this is in your formula book, but it's not in your formula book altogether. So this is a prime example of what IB is trying to get you to do, which is to be able to break it down into the surfaces that you do know. So you know that the circle, that the base is a circle. So your formula book has the area of a circle. And your formula book has something called the lateral surface area of a cone. And it's also on page 6. And that's what it means, this lateral surface area of a cone. So it knows that you want to find that, and it gives you the formula, but you just have to know how to use it. And that's what the IB is testing you on. A sphere is pretty straightforward. It is very formula based. It's kind of hard to break it into surfaces and to piece it together. So this is in your formula book on page 6, as well as your surface area formula book, page 6. All right. A cylinder. A cylinder, the volume is area of the base times the height. In this case, the area of the base is a circle, so pi r squared. Also in your formula book, I think it's pi r squared h labeled on page 2. So your formulas for three-dimensional geometry are split into what they expect you to know as prior knowledge. And this is on page 2, so they expect you to know this from prior knowledge. Who cares if you remember it or if you have been taught it? Just know that that formula book is there, or that formula is there, and it's just under something that they call prior knowledge. The surface area is going to be your two bases. So the bases are those circles on either end. I like to think of it kind of as this tunnel. So it's the ends of the tunnel. So you've got two of those areas. So you have to make sure to do 2 times the area of the base plus 2 pi r h. Really what this, and this is again the lateral surface area of a cylinder. Only the lateral surface area of a cylinder is represented on page 2 of your formula book. So again, you just have to know that you're taking that lateral surface area and adding on the 2 bases to get your total surface area. So can you use these formulas in order to then find the answer is what IB is testing you on. Realize that 2 pi r is the equation for a circumference of a circle. And if you take a piece of paper and you wrap it around like this, you have made a cylinder. And the idea is that when you unpeel the cylinder, it just turns into a rectangle. And so this rectangle, how you find the area of it is it's just base times height. This is the height of your cylinder. And then the base of your rectangle is the circumference of your circle. And so 2 pi r represents the circumference and h represents the height of the cylinder. And that's how you find the area of the lateral surface. It's in your formula book. Just realize that it's there. Those were my notes. The volume of a cuboid, in other words, a rectangular prism, is in your formula book. It's just all 3 of the dimensions multiplied together. So length times width times height. The surface area, unfortunately, is not in there at all. So this is just something you need to know. The number one thing to remember is that opposite surfaces are the same. And so if you have a total of 6 surfaces on this cuboid, hopefully realize that since opposite surfaces are the same size, that you really only have to find the area of 3 different surfaces and then multiply each of those surfaces by 2 before you add them up. So find the area of one guy, multiply it by 2, find the area of a different guy, and then multiply it by 2, and then find the area of the third guy and multiply it by 2. So broken down, It's 2 times length times width plus 2 times length times height plus 2 times width times height. So I'm just taking all three of those dimensions, multiplying them together, multiplying by 2, and then adding the results. Not on your formula packet, yes in your formula packet. Okay, the volume of any prism, whether it's a rectangular prism or whether it's a triangular prism, will always be the area of the base times the height. In this case, the area of the base is the area of the triangle. So the base is always the shape that makes it that certain shape, right? We know that this is a prism, but it's specifically a triangular prism, which means that the triangle is the base. We know that the cylinder is actually technically a prism. It's a circular prism. And so the base for this guy is going to be a circle. If it was a pentagonal prism, in other words, a five-sided figure for the base is a pentagon. So that's what we mean here by a base, but it doesn't have to be at the bottom. So notice here that the triangles are not on, like, sitting on a triangle. It's sitting on its side. So still the triangles are the base here because it's what defines that shape to be a triangular prism. And also realize here your H, your idea of H, is now also labeled as L, because H is really just the distance between your two bases. Because you could put that cylinder on its side and the height would still be the same, right? If you took a cylinder and laid it on its side, the height is still the distance between these two bases. So a lot of students get really tripped up on what the idea of height is and just realize that height for our volume formulas really just means the distance from base to base. When we're talking about a prism, when we're talking about a pyramid or a cone, we're talking about the vertex to the base. So it's that like perpendicular distance from the base. That is my words of warning to you. The surface area here is not in your formula packet at all, so you really do have to piece it together. The surface area is going to be 2 times the area of the base because you've got 2 different triangles. They're going to be the same size, so find the area of one triangle and then multiply it by 2. And then you have to add on the area of all of the rectangles. And so it's going to be one side of the triangle times the length, and then one side of the triangle times the length, because that's how you find the area of a rectangle is just the 2 dimensions multiplied together, length, width, base, height, that idea. And then another side of the triangle multiplied by the length. So you're really taking all 3 different sides of the triangle and then multiplying it by that length. So bear with me. The area of all of the rectangles is going to be, let's label this A, B, and C. It'll be A times L plus B times L plus C times L, which is L times A plus B plus C, right? Just factoring out L, bear with me. A plus B plus C is the perimeter of the triangle. And so really how you find the area of all 3 of these rectangles is that you can do the perimeter of the triangle times the length. And so that's kind of a nice trick if you know it, if you memorize it, if you remember that rule, awesome. But all you really need to know how to do, if you're not a big like memorizer of tricks or of systems or of processes, because it won't be given to you in a formula packet, just remember that you need to break down each of these sides into their separate sides and find the area of each. And so in this case, there will always be 3 rectangles when we're talking about a triangular prism. And so find the area of each of those rectangles.